All right, here we are, week 18. Last week of this quarter, and after this, we get to take a break. Hooray! Next Friday is a break week. I'm going to really look forward to that. I'm actually making these videos, what is it? It's November right now, but I know that on week 18, I will be excited that there is a break coming up. So I can say that with genuine. All right, so we have two experiments this week, push up and tip. Okay, so push up is a really straightforward, easy experiment to do. Tip requires a little bit more navigating. So you decide whether you'd like to do the one that takes more time first or second. Either way, it will work okay. Push-up is these are actually both demonstrations. They're not an individual experiment or really anything that the students are going to get hands-on with. But that's okay, because it's week 18, hooray! Okay, so we will have our normal jug of water. I just didn't have one handy, so I'm using a vase. So we're gonna fill up our bowl 3/4 of the way with water, and thankfully that worked out great. And then we're going to take our cup, turn it on its side, push it beneath the surface of the water, which didn't work. You can tell I did not test this beforehand. Okay, let's see. So I can use my candy water here. Get enough in here. No, a little more. Okay, so make sure, directors, if you are not on my campus, that before your tutor meeting, which this is November for me. We've not had our tutor meeting yet. Our tutor meeting is in January, and this is the only experiment that I did not test out before I started the videos, and I thought I would just do a couple, but it turns out I'm on a roll, so I'm getting things done. So hold on, I'm gonna go get a little bit more water. But make sure you test the size of your glass with your bowl. Actually, you know what? I'm gonna do a different glass. We are just going to do, we're just going to use a different glass. That's how easy we're going to make it. Hopefully. Let's see if this works. All right. Perfect. Okay. So turn your glass on its side into the water. So it needs to be completely submerged. And then turn it so that the mouth points down. And lift the glass, leaving about 1 inch of the mouth of the glass under the surface of the water. And you will see and you'll feel it, and you can even actually have each student come and feel the resistance. There is such a pull, such a suction on the glass where the water is, the air pressure and the water is holding it down. And this is demonstrating atmospheric pressure. And definitely the air pushing down on the surface of the water outside of the glass extends upwards hundreds of miles, and the pressure of this air is called atmospheric pressure, and the pressure is great enough to support the weight of the water inside of the glass. Thus the water level inside the glass remains higher. It's all the way up. So this is really fun, and your students can feel that, and you can talk about why, and reading the Van Cleves is perfect for them to hear it. You do want to define some terms. What does atmospheric mean? What's pressure? Does it exist? And actually, on that note, I think it would be better to do tip first, because that's where we're going to demonstrate that air has weight. And that will be the perfect segue into push-up, which is why it's numbered 139 and then number 140. So do tip 139 first, because then we'll get to assess that air has weight. All right, so let's do that one. Okay, we need modeling clay, which I have, a yardstick. I have a yardstick, but the last time around in cycle 1, I ordered my supplies from Lighthouse, and they sent me an 18-inch ruler, and that worked really well for this experiment. So I plan on using it again, unless we really feel like we want to use the yardstick. But so you just want to tie. Oops, I'm going the wrong way. Tie this on in a way that it pretty much balances in the middle, and then get some string and a balloon. Get a balloon. All right. So inflate the balloon to its maximum size. All right, this might not be maximum, but I get nervous that balloons are going to pop in my face. So this is the maximum that Mrs. Seiler is going to do. Okay, so we tie it up, and we tie this string onto the end of the balloon. Okay, because we are going to then attach it to, am I doing this right? Yes, I am. Okay, good. So we're going to tie the string onto there. Okay, we're just going to cut a piece, there we go. And we're going to tie this to the end of our yardstick. Where on our yardstick, how long should it be hanging down, all of those things. Those are good questions. You can use them as I wonders in your class. I wonder what would happen if we tied it closer to the yardstick or further out along the end. But I'm just going to tie it here and see what happens. Science is not about perfection. It is about trial, error, guesses, hypothesis, and observation, really. So let's observe what happens when we tie it here. Okay, and then we need some clay. Now, we don't need a lot of clay because air doesn't weigh a whole lot. So let's start off with that amount of clay and see if that's too much or too little. This rope is, okay, so too little. Let's add some more. I don't know if you can see me if I stand up, so I'm staying seated, but I might change that. Okay, here we go. Woo, look at that. Relatively even. All right, so I have about that much clay and a 9-inch balloon, some string, and some air. That's what we've got. And it's pretty well balanced. And you can always adjust the location of the rope in the middle instead of fiddling with the clay to sort of find a balance. So good, we found it. Take our tape and put, okay, this always makes me nervous. All right, so take the masking tape, about 1 inch long, to the side of the inflated balloon near the neck. Okay, that's important, near the neck. Okay, there we go. All right, now we should make sure it still balances because tape also has weight. So let's see what happens. Still good, right? We're still good. Okay, now we're going to take, so you need a parent helper here so that they can hold the string. All right. So I'm going to, oh my gosh, am I going to do this? I'm going to hold it with my teeth. Okay. All right. Now, okay. You put that in there, and now you're going to remove the pin and see what happens. Okay, I think I can do this. Okay, here we go. Well, nothing happened because it did not poke a big enough hole. All right, let's try this again. Oh no, it's coming out slowly. It's slowly, it's very slow. But you can see how this is starting to sink down because it's becoming heavier. So one of the important grammar level ideas before you do this is if the students don't understand that something heavier tips down and lighter tips up, they're not going to understand what's going on here. So it's probably a good opportunity to maybe even put, if you want to extend this a little bit, we'll have a big piece of clay. Maybe you can put 2 pieces of clay on there and see what happens. You can ask them, do these pieces of clay weigh the same? Would they weigh the same? And they could clearly see if one's larger and one's smaller. No, they don't. And then put a piece of clay on each side and say, what happens to the heavier side? It sinks down. And then make it so that it's even. I mean, you could expand it that much if you have time, but definitely getting them to understand that heavier drops, lighter goes up. So you get the gist. You can even squeeze some of the air out of the balloon, or maybe even poke another hole in to make that go a little faster, or have a parent squeeze, or have each of the kids come and squeeze. They'd like that. But ultimately, that's what we're doing. My campus, we're going to continue using this 18-inch ruler instead of the yardstick because I just think it's more effective and less unwieldy. A large yardstick can be a little unwieldy. Okay, so for some additional verbiage for week 18, tip and push up. Okay, so tip. To determine if air has weight, that's our purpose. And for younger classes, maybe asking if they know what weight even means. Actually, for all classes, I think, again, it's really important to define our terms. Is there air all around us? Do we feel it? Does it feel heavy on us? But does it have weight? How can we test whether air has weight? And then you can blow up a balloon and say, do you think the balloon with air inside of it is heavier than a balloon without air inside of it? Let's see. Let's test if this balloon, if this air has weight. And so first you'll blow up the balloon, you'll set the clay, you'll balance that. Of course, we just did the experiment, so you get a chance to see it. Why did that happen? Of course, air has weight. As air leaves the balloon, the side of the stick with the balloon becomes lighter and it raises up. The Earth is surrounded by an ocean of air, which weighs so much that every square inch of the Earth supports about 14.7 pounds of air. And that's actually really important for our next experiment because we're going to feel that weight. Air is a substance, and all substances have weight. Air, however, is very light. A column of air in a square inch extending from sea level upward as far as the atmosphere goes weighs about 15 pounds. This is called atmospheric pressure. Galileo first demonstrated that air has weight by weighing a glass globe, then forcing air into it and weighing it again. He correctly ascribed the extra weight to the added air. An automobile tire pumped up would weigh more than a flat tire, but the difference would be too slight to detect on ordinary scales. But I'm sure your students can come up with some additional examples of air having weight. But moving on to push up, I would move into that one saying, so we just showed that air had weight and that weight is called atmospheric pressure. Now let's find out how strong that atmospheric pressure is. Remember how many pounds did we say was per square inch? They'll be all like 15 or 14.7, whatever. Say, let's see if we can feel that. Then you'll do the experiment and then say the water doesn't pour out of the glass because the air on the water surface has weight and is pushing down on the water surface outside the glass. This provides enough pressure on the water to keep it level, which keeps the water inside the glass. And the Van Cleves says air pushing down on the surface of the water outside the glass extends upwards hundreds of miles. The pressure of this air is called atmospheric pressure. The pressure is great enough to support the weight of the water inside the glass. So I know I said that pretty quickly to you, and you may or may not have caught it all. You may need to go back and listen to that again. And if you have to do that, I just want to encourage you to simplify for your students or to speak even more slowly because they're trying to grasp each sentence that you say. And when we say a bunch of sentences that have words that they don't understand, it makes it harder for them to keep track. And they will either not understand or they'll go, what? And you'll need to repeat yourself. So I hope those extra descriptions were helpful, and I will see you on Friday. So that's it. That is all of our science experiments for this quarter. God bless you. I can't wait to see you on Friday. And if you have any questions, don't hesitate to let me know.